I think we were 26,600 plus people, had almost 27,000 people have gone through and read prior presentations, and we are now videotaping. If you haven't had a chance, you can go to the archive page and it'll give you a link off to watch the previous two presentations in, well, they're sort of in an archive format. I'll be kind about that. I wouldn't say they're professionally done. We turn the tape on, we just let it run. But you can get the full words and everything, and you can actually put the presentation up in a separate window, let the words run in the background, and kind of follow through, so it's pretty good that way. Hopefully we'll have this presentation up in about a week or so. And now I'd like to introduce the speaker, the man standing next to me. I've known this guy since 1995, but that's only about an inch and a half out of his yardstick of experience with the internet. He goes way, way back. He is truly an internet pioneer. The way I characterize it is, he worked for Vint Cerf before Al Gore did, you know, in making the internet. He really was one of the guys creating the internet. He is the author of RFC 822, which is the seminal definition of what email is. And email, in my mind, is the killer app for the internet. Nothing else on the internet has had as big an impact on people or is as widely used, even the web, as email is. That also implies, and it's true, that he's been very active in the Internet Engineering Task Force, going way back, I think, and for sure until the 80s. I don't actually know when you got active in
the modern idea started in '89.
So I can't go back probably that, but he's been very active. That chaired various different groups of that. Also been manager for various networking companies around here, including VP of engineering for Wollongong. And if you go way back in TCP/IP and engineering, you know Wollongong as the name of the guys that were doing the early TCP/IP. So he's really been there. Since that time, he has been involved in a number of startups. I think he's a startup a year almost type thing, the way things go in the Valley. But an excellent speaker to give us a review of where the internet's come from, how it got to where it is, and what it's likely to be doing in the future. So, Dave, thank you.
Thank you, Bill. Let's see. This is not on, I gather.
Should be.
It's
just
pretty quiet. And I'll just guess you guys can hear me. And I assume there's a microphone on that that's doing its thing, and it'll get whatever it gets, okay? So good evening, thanks for driving in. Lovely weather we're having. I hadn't understood the level of flooding they were having down in Los Angeles until I just saw the news. But apparently the rest of the world thinks we're all underwater. And perhaps some of the drivers for tonight were also. The title is whimsical because, frankly, I find most history discussions and future prediction discussions to be either boring or silly or both. And so I figured that rather than pretend it wasn't silly, I'd just give in from the start. The other is that predicting the future is fun and generally, I think, useless except as entertainment, unless you're talking about the future as in next week. But somehow I don't think that's worth bringing people to a presentation for. So what I want to do is make sure we understand what this interaction is supposed to be about. Bill went over my background. I have a pro forma slide that I'll do very quickly. And then the next three bullets are not really so much in order as the kinds of things that I'd like us to take a look at, which is some of the things that have happened in the past, where it's not so much interesting what happened when, as much as what kinds of things were happening and in what sequences, and what kind of space was between them and who did them. These turn out, I think, to be far more interesting than particular milestones of internet capability. And that's where the analysis comes in, is trying to understand what prompted these changes, and from that, perhaps take a look at what sorts of things might happen. So I just said what this is about. if you discover that a particular assertion I make is factually incorrect, especially if it's about time, don't be surprised. I made a point of not trying to do research on this, so I called for my memory. And I'm old enough now where that's a particularly dangerous thing to do. My reason for choosing to do it is the frame of reference of time is what I'm really interested in, rather than giving you a textbook kind of accuracy for the specific day, year, and month. I already said that. So, Brandenburg networking. I think there's not much that Bill did not cover. The only thing I'd want to emphasize is that most of my work has been in email or email-related activities, except for a number of years I actually did earn my living running TCP stack development. And so for about the first 10 years of my career, I was in the research community, mostly doing applications and documentation and user stuff, and keeping away from the lower layers with a fairly arrogant attitude that give me a pipe that's reliably sending bits and I'll do the interesting stuff. And that came back to bite just under 10 years later, when I actually had to do TCP/IP stacks and get into the lower layers, and in addition get into some network management activities. At one point at Wollongong, we had somebody from Wollongong participating in each and every one of the network management standards activities. There was a huge war going on between the OSI CMIP standard and an emerging IETF standard, which came to be SNMP, which is now the standard. And we had people either in charge of documenting the standard or running the working groups for all of the related activities on both sides. And that led to one of the industry magazines writing an article that said that we were, that Wollongong was the industry leader for vendor-independent network management. And that was pretty cool, except we didn't have any network management product work. We were just being nice guys in the standards. I looked at that and I said, this is a marketing opportunity that's too good to pass up. So we went out and got a version of some freeware that was available from one of the NSFNet regionals called NiserNet, later became PSI, and started a workstation project, just because if we had this wonderful market position, we'd probably be able to make some money selling it. What I discovered then, as I had experienced before and far too often have discovered since, is that having a really good product isn't enough if your marketing department hasn't a clue how to sell it. And so we had a layoff not all that long afterwards. We had a really good product. Had a layoff not all that long afterwards, and I had to figure out where to cut. And the president of the company said, well, we don't know how to sell all this network management stuff. So that decided where the cuts were made, in spite of how good the work was. That's a topic that I suspect people are a little familiar with just now. So what do I do? Bill covered that. I don't think I need to go into it a whole lot more. My comment about marketing is that I've been increasingly discovering that building technology is a lot of fun, but it's not the most useful thing to do. And the reason is that no matter how good the technology is, if nobody knows how to sell it, if no customers understand why they should buy it, they don't. So we're going to spend some time on this slide, and I would like to encourage folks to interact. You may not have noticed on the agenda slide it said what we will discuss. This is a small group. This is really an informal topic. It will be way better if we chat about things. So if you have questions, reactions, corrections, dive in. And I think we'll all have a better time of it. Purpose of this slide is to look at the timeline of development that we've had over the net. And I'm starting with bandwidth because that's essential and not in the least interesting. We can't do without it, and we shouldn't be too excited about it. Other than to note that the rate of increase has been pretty remarkable, and that what we can do today is really astonishing compared with where we started. The original ARPANET in 1970 was a 56 kilobit backbone everywhere. It was intentionally the same bandwidth everywhere so they wouldn't have to get into any of the differential performance. Later on, variable or mixed speeds were allowed in the net, but that was probably 10 years later. And dial-up, or user access, which is what the lower numbers intended to show, 1200 bits per second unless you were in some fancy university computer science department hardwired. I remember that at UCLA, most of our terminals were in fact slower than that. We had one hard copy terminal that went at 1200 bits per second, 120 characters a second. And that was really astonishing. I mean, it's just incredibly fast. And we had a visitor from MIT, a guy named Marvin Minsky. And for those not versed in computer science history, that's a fairly important MIT name, especially in AI. And he was on vacation, and he'd stopped by to check his email. This is about 1973 or 4. He had his kids with him. Now, his kids are growing up at MIT with the kind of resources they had. And at one point, I was typing on this 1200 bit per second terminal, really enjoying its blazing speed. And Minsky's son sort of watched for a while and then turned to his father and said, "Dad, why is this so slow?" And that's a phenomenon that was true then that we still experience. One of the messages that I like to point out to people that I've discovered in watching what the reality of resources is around the net, around the whole net, is that we get used to capabilities around here in particular, unless you live in Sunnyvale where I do, and then it takes longer. We get used to, it was the test bed for cable television, for cable internet access, and they could not deliver it to my home, because it turned out that the Sunnyvale cable plant was about as bad as you can get. And the folks at Home worked really hard to try to figure out a way of fixing that, to get me on, and they couldn't. But that kind of disparity of what the best is versus what the average is versus what many people experience is something that we lose track of very quickly in these kinds of environments. We lived in Malaysia for a year at a university about 20 miles outside of Kuala Lumpur. We had good resources there, nothing to complain about. We had two sources of subscription television access. One was a satellite and one was microwave. There was no cable, there wasn't likely to be cable. It's not a real good environment for laying cable. It's a little wet there, much worse than this. And it's wet all the time with high humidity. And around that time, people in the US were going that interactive cable access was going to be the future of the internet. And so I'm trying to figure out how that's going to be true in much of the world where there will be no cable. There will be satellites, there will be other kinds of services, but there's not going to be any cable for a long time to come. The bandwidth, I have some of this in bold because I think they're particularly significant. And what I found interesting when I was putting this together is if you can get DSL and off of one of the comments from earlier, and if the company that you're getting it from stays in business, then you get a roughly T1 level of access, at least in a download. And if you want to pay some more, you can get a little better than that. But T1 is not so much the average access today as it is a reasonable high end to shoot for. I'm actually suspecting that while there will be pockets of better performance 10 years from now, or certainly 8 years from now, I have a feeling it's not going to get all that much better in any wide scale. Now, why would that be? Well, first of all, it's going to be a few years before the telecoms pick up. They have shot their wad for some years now. And the other is, what does it take to get a large number of users to higher bandwidth? What does it take to upgrade an infrastructure over a long period of time? And the answer is a long period of time. 10 years for upgrading this sort of infrastructure change. 10 years would be blindingly fast. And so my guess is that we're in the phase for home access that is going to be dominated more by fleshing out the service, making it more reliable, and making it more ubiquitous for internet access to the home than it will be for giving you very high bandwidth. See, it turns out that there's now fiber.
You want to be interrupted.
Okay, yes.
What about cogents and guys like that?
I didn't say that no one is going to be capable of doing it. The question is large-scale deployment. Because
you guys heard of cogent?
What was that?
Cogent.
Cogent could give you 100 megabytes to the door if there's fiber.
Right. See, there's fiber into your neighborhoods pretty regularly these days, and even that is not as ubiquitous as we might like to think. But folks might know the term the last mile, which referred to from the central office of the phone company to your home, and that's now sort of become the last 100 feet, because as they get fiber to your neighborhood, they don't have fiber to your home, because it's one thing to lay it down a street, and it's another thing to lay it into every single home. The cost of doing that is really enormous. And getting 100 megabits per second to your home is dandy, except that you're not going to have any mass market use of that. You're not going to have any vendors selling services that rely on that until you have a very large number of people who have that base available. Around 92, I saw a reference that said that the definition of a mass market is 2 million potential customers. Now, my wife teaches marketing, and she'd never heard that term, that number. And I don't know that it's the right number, but it feels like a good number. That's a large enough number that you're really into some interesting scaling for potential customers. And the importance of that number is going to show up shortly. Probably, if I had to think about it some more, I would guess that what we're going to see is a kind of digital divide in which there's the major mass market and then there's the high-end mass market. We don't have a whole lot of that right now, but the likelihood is that we will in the future. And so there'll be people with higher bandwidth or bandwidth at any time from all sorts of devices. We're getting the beginnings of that now. The 3G stuff that we're all expecting. Everything I'm hearing is it can't actually handle the capacities they're promising. So you can get very, very high bandwidth that no one else in your sector is using it. Well, that doesn't sound very good. Then there's a question of the size of the net. And at one point I was going to try to do the number of users versus the number of providers, but I decided just talking about users was enough. ARPANET, roughly 100 people. Maybe it was double that, but it's still a tiny number. By around the mid-70s, the ARPANET was a production environment, which caused problems because officially it was still a research network. And it would, in fact, occasionally be taken down to run a research project. And that became the impetus for later splitting the ARPANET between the research side and the military production side, which took place in 1983. Its growth stayed very constrained because it was a Department of Defense resource. You had to basically have a Department of Defense tie of some sort in order to get authorized to get on, and it was very expensive, very, very expensive. In 1975 dollars, I think it was $50,000 to attach. It was hugely expensive, and that's the attachment. That's not the yearly operation. And so there was an interesting digital divide then. If you were a top-tier academic environment or research house, you were on the net, and if you were the rest of the world, you weren't. And that created some very big disparities in what people knew about and understood about data communications, but also collaboration between universities. Because once one part of the university was attached, then all of it could be under the same permission. The growth rate stayed just fine, although it was not all that fast. The estimate I heard is that the internet doubled every 13 months, starting from its beginning, continuing through now. That's kind of astonishing. So when you hear about how explosive the growth of the internet is, well, it's actually the same statistics pretty much all along.
And never changed. It was smooth.
To my knowledge, that number that rate of growth has stayed the same. On the other hand, when you start with a big number, then doubling in 13 months gives you a really big number. And so the estimates I saw, and most of these estimates were wild-ass guesses. There was, in fact, no internet census. There were all sorts of attempts to guess. Some of them were actually pretty reasonable. And the guess was that around 93, we hit 2 million. And I have that bolded and in color because you'll recall, I think that's an interesting number for mass market. One would predict that somewhere around that time, we'd see a major change in the development and use of resources on the net in the early 90s. The estimates today we're in the ballpark of 100 million, although I've seen some estimates that are much lower than that. In 96, this is before we actually lived in Malaysia, I was on the eastern side of the peninsula, a town of 400,000 called Kuantan. And we were standing around waiting for the local sultan to show up. And they had various police around, and one police sergeant actually knew how to speak English, so he was chatting with us. Very friendly guy. The instant he found out I was involved with the internet, he said, "I want to sell your products." I didn't have any products. I didn't say I had any products. It just turns out Malaysians are extremely entrepreneurial. He didn't actually know anything about the internet. And in fact, at one point it was really interesting. He said, "Now the internet, I know you have the internet in the US, but I'm not sure, was it invented in the US or was it invented in Malaysia?" And laughter is the usual reaction that I get when I say this to people. And it was certainly the reaction I had, although I didn't show it because that would have been rude. But then I thought about it a little harder, and I said, and I've decided that if you wanted to look for a measure of success for the diffusion of a new capability, you could not do better than having people think it was invented in their home place. It was that well ingrained. And in fact, about a week later, when I needed to connect into the internet, and getting an account with a local ISP in those days was really tough. It turned out there was a cyber cafe on Borneo, where I was. And it had Chrome and fancy sandwiches and the whole bit. This was in 97. Yeah?
You said they didn't have cable, any sort of cable TV. How did they power cyber cafe? Was it going over phone lines?
Okay. How did they power the cyber cafe? And actually that raises, this is a more interesting question than you may even have guessed. The phone company resources were mediocre or poor. You could get a phone in your home. It was reasonably reliable. We actually found that we could get our cell phone working within about 4 hours of deciding to get it, whereas it took 2 weeks. But that may have been because it was the university doing the actual work. On the other hand, when it went out, it was another 2 weeks before it worked again. So the dial-up lines were the normal 9600 baud kind of stuff. I mean, don't even think about 56K over those phone wires. But you could get higher bandwidth into business locations if you paid for it. And did they pay for and in fact, actually, now that I say that, what they got was ISDN. So they'd have 1 or 2 channels of ISDN. So 128K, or maybe they'd kick it up to 144 if they did it the fancy way. And you might go, well, that's terrible, but compared to nothing, it's great. And in fact, the other significant thing is that for much of the country, and I think I class Malaysia as a second world country. In the U.S., we have this peculiar sense of we only have the very top tier, and then everybody else is totally deprived, and it's just not right. They have actually a pretty good economy, huge middle class, a lot of infrastructure, fairly stable political environment, and those are not the things you'd say about a third world country. On the other hand, the situation had some fragility to it. The economic status of people was not as plush as in Singapore or the US or lots of other places. So not everyone could get the internet to their home simply because they couldn't afford the PC, or they couldn't afford to tie up their phone line, or they might not even have one. And so in fact, in much of the world, internet cafe structures are extremely helpful because they're a neighborhood or a community resource. And in the US, they haven't been all that successful, but in much of the rest of the world, they're incredibly successful because they are a place to bring that scarce resource of high bandwidth and, oh, by the way, expensive computers. Now, in those days, plugging your laptop in was the odd thing because they weren't designed for that. They were just, and when I walked in, I wanted to plug in my laptop, and the staff person freaked out, handed me to the owner. The owner was a travel agent who had been spending $500 a month on faxes, and a friend in the US said, you know, if we could do email, it'd be real cheap. And it was. And he looked at that and he said, this looks like a business opportunity. And that's why he opened the cyber cafe. Decided that if it was that good for him, it would be that good for lots of others. I'll give you a related anecdote. No, I think I'll actually save that one.
Never heard of DHCP though. As well. Configured TCP/IP.
DHCP is in some of these places. I haven't been to a huge number, but I've been to a few trying to plug in a laptop. And I'm now discovering that frequently, but not always, cyber cafes or internet cafes can handle the idea of a laptop. Most of the time they don't do DHCP because it really isn't their business model. And they want more control over who plugs in. In Cusco, in Peru, the university actually ran a commercial cyber cafe with this incredibly old Cisco router. And I asked them in my extremely broken Spanish why they didn't use DHCP, and they pointed at the box, and the box was like half the size needed for the extra code, and they couldn't afford the change. Okay, so if we have 100 million now, I'm going to roughly guess that by 2010 will be roughly half the population of the world will have some internet access. I actually don't think that's a very interesting number because we are largely. Could you do me a favor?
Yeah.
Please.
Yeah.
Sorry. We are largely already at the level of global mass market, and we are already at the level where families around. Thank you. Families around the world use the internet as a means of maintaining family ties. There's been a little of that going on for a few years already, and it's become really quite common. I remember actually meeting an Alsatian dentist who had just retired, who had reestablished contact with family in Texas and California through the internet. And he lost touch with them. This was just a few years ago. He had lost touch with them as a result of the spreading of people from World War II. So it had been that long, and he was able through the internet to obtain contact. And so going up to 3 billion is going to be real important in terms of continuing to make money and entrench and become a natural part of everybody's lives. But I don't think it's going to put extra demands on creating products or the like that we don't already have.
I was going to say, lately there's so much gloom and doom, especially here in the Valley. The internet's over, or not over, but the best years are behind it, so to speak. I mean, when you look at that number, it's breathtaking to imagine the number of new businesses, the new opportunities that are going to come. Do you really think that number can be reached, in the next 7 to 8 years?
It might be aggressive, maybe it'll only be 2 billion. But 2 billion is not bad. What we experienced over the last 10 years was a gold rush. And
if you think of 3 billion is like everyone.
Well, it's actually, it's not. It's less than half the world by that time.
And, okay, but you got a ton of people who are just simply too young to do anything, and you got a bunch of guys that are beyond the point of wanting to do anything. So you don't have to worry about the middle. And if you get 3 billion out of the middle, you really have done it.
Well, except that we've got such lengthened lifespans where
Right.
people function much longer than they did. So that middle is pretty large.
Especially with the 401ks.
Right.
So would you consider accessing the internet through your cell phone as part of your
I'm sorry?
Would you consider the accessing internet through your cell phone as part of your monthly?
Oh, so accessing the internet through cell phone, would I count that? Oh, absolutely. What the heck? I'll give you another anecdote. I want to say Kobe. Yeah, Kobe about 2 years ago. In this very interesting little restaurant, we got friendly with the people who ran it and decided that we wanted to be able to send them email. So I took some pictures and I wanted to send it to them. The only email they had was their daughter's Docomo cell phone. And they never actually answered me. It turns out there's actually now a substantial fraction of the internet that is really only cell phone based. And it's completely viable. I mean, for me, the trio actually is the critical mass capability, where things integrate well enough, and never mind that the bandwidth sucks right now, that'll get better. But the capability of that device and the size of it strikes me as really being quite good, much as the Palm was the breakthrough PDA device. And I hope folks remember that the Palm was a breakthrough after 10 years of failed efforts. There were huge numbers of efforts almost 10 years earlier to do great PDA kinds of things. And so, like with most breakthroughs, there's actually some pretty interesting history. Yeah.
What about the impact of Wi-Fi on internet access, especially if the plan of providing universal Wi-Fi access comes true?
Right.
Every man and his dog can access the internet.
Right. So what's the effect of the wireless access, in particular higher speed Wi-Fi 802.11 star? It's great stuff. It doesn't work too well in a moving car, and that's not a trivial point. I mean, what we seem to have as reality is that there's a spectrum of ways of accessing the net. Or maybe I should phrase that as, there's a range of communication technologies, and if you hook them all together right, and you have enough of them available to the user as a mix, then they could probably keep in contact where the only experience they would suffer is differential throughput. Now, it's worth noting that today, if you have a TCP connection and you move, and that move is not transparent to the internet technology. So if the move is handled by the lower layers, then it all looks like you've got the same IP address the whole time. Then your TCP connection is maintained. But if you actually have to make a transition that is seen by the IP layer, you lose your TCP connection. Now, it may be easy to plug back in and get reconfigured. DHCP, as Bill was mentioning, is really good for that. But if you are doing something that needs serious continuity of communication, the current capabilities don't allow you to do that. It turns out, very oddly, in my view, that kind of mobility that you would need to support is really quite similar to supporting good multi-homing, because it reduces down to having multiple IP addresses at the same time. And you can't do that with TCP, and you can't do that with IP version 4. There is a claim that SCTP, which is a new protocol at the TCP and UDP level, will allow that, and that it's intended for reliable datagram service. We'll see. A few years ago, a couple different people had an idea for making it actually pretty easy to do that kind of mobility, and it didn't catch on. No one in the technical community seemed interested in it. So we clearly have an explosion happening with hotspots. I went into Tide House, downtown San Jose, a few weeks ago, had about an hour to kill, walked up to the bar, sat down, and asked the bartender whether they had wireless access. And he actually looked insulted. Of course they did. And it worked, and it was, and the problem was, let's see, if I remember that place, the carrier that they use was some weird service. And so there'll be, as there have been for every other service that starts on the net, there's a shakeout with some flaky guys that start up and don't do a very good job, and then some others that aren't flaky and do a good job. It certainly looks like T-Mobile is being very aggressive, and oddly enough, the traveler's version of the Internet Cafe in the U.S. appears to be Starbucks. I've been relying on that in the last few weeks quite a lot, and saved my hide, because at one point I was staying in a hotel that had advertised internet access, but what they meant was dial-up. Colored me very irritated with that hotel. On the other hand, the Grand Hyatt downtown San Francisco, just for the heck of it, I was again killing time. They had wireless running, the page, and they had an intercept, and the page that started said either dial extension 56 to get authorized, and there was no phone anywhere inside, I was in the lobby, or click here. Presumably click here would take you to one of these standard login things. Well, click here took me back to the same page. So we're in that startup transit. So I think that the concept of the hotspot is probably totally safe for sitting down and doing some work. If you want the drive-by data exchange that you hear people talk about sometime, it's not clear what's going to do that. And there are discussions about having natural trade-offs between 3G or equivalent metropolitan area networking and Wi-Fi when you're local. And my guess is that's actually kind of the right model, is your device will have some number of ways of connecting, and they will have differential performance. And they'll get better or worse depending on which direction you're traveling. It doesn't look like there'll be any single killer technology there. Having said all that, in case you hadn't noticed, I don't do hardware very much. And so this is just my sense from standing back and watching what's going on, and basically being a user that really wants this stuff to be working today. Okay. So, what actually has the internet been used for? What's been the development of capabilities on the net? And this, frankly, for all that this has been going on with the first bit, this is where I think things are interesting. The next one is going to be interesting and difficult. We had a burst of capabilities in the earliest days of the ARPANET. The ARPANET was first demonstrated in the fall of 1972. By 1973, all the applications were running. Email, file transfer, terminal access through Telnet. Most of them were demonstrated in the fall of 72. I'm going to ask a trick question. I'm telling you it's a trick question so you don't give the obvious answer. When was the web invented?
94.
One guess at 94.
86.
One at 86. Bill says 89. Berners-Lee did his work in 89, but as I said, this was a trick question. 1965.
Oh, no. We're not going to count
Yes.
Ted Nelson.
No. And we're building a guy named Ted Nelson who created the term hyperlink. And he was at Brown on the East Coast. And were that the only thing going on in 65, then no, I wouldn't count that. But you'll see a little thing on the left there that says NLS. SRI had a research project called the Augmentation Research Center, started by the principal investigator was a guy named Doug Engelbart. Now, many people think the mouse was invented at Park. It wasn't. It was invented by this group. And that's a big deal, but that's actually not enough to claim, well, that was the web, of course. The system that they had running in the latter part of the 60s, and I was using it in the fall of 72, and it was basically version 2 or 3 of their system, was a shared environment for text exchange. It didn't do graphics. The Park people added that. And that was only about 3 years ago, about 75. It had dynamic links, textual links, that you could type and click on and it would take you over to another document. It was not network-based. in the sense that the documents were all in a single repository. But from the standpoint of the technology that they had, it was actually a trivial update. Now the project died down, got bought by Timeshare, and then essentially went away. They tried to market it, but it was a little difficult to use. It took about 3 months to get competent at using that system. So the levels of usability have gotten just a tad better. But I think that if you ever have a chance to look at descriptions of that system, you will see the core of what the web is really about. And by and large, in fact, Berners-Lee did not invent anything other than the whole system. Every idea in the web was extremely well established, had been around in various forms for a long time. What hadn't existed was the integration of them in a way that balanced utility with ease. And that was where his real cleverness came to bear. And it turns out that if you look at Unix, going back to '69, Unix is generally characterized as not having invented any computer science constructs. And it turns out the setuid bit is sort of the only possible exception. Everything else was taking well-established constructs and getting the right engineering mix. And I mention these two examples because I think there's a lesson to learn there as we try to do things in the future. We have a tendency right now in the internet standards arena that people are trying to build big systems. Well, that's what the OSI people did. And big systems are not only big when you built them, they take a long time, and they're big when you design them and when you write specs. And all of that ends up meaning you miss the market opportunity. And somebody comes along with a little system that does a little bit, but quickly. Early 80s, we had, and I mentioned email, even though it was earlier, because at least now we got our own protocol. Email in the earliest days was a special couple of commands in the file transfer capability. And the main deficiency with that, the only real problem with that, was you could only do one addressee per copy of the message. And that doesn't scale very well. So with SMTP, we now can have multiple addressees. And it occurs to me I left off a fairly important item up around the early 90s that I'll mention as we go on. The DNS, how many people know why the DNS was invented? You don't count. Yeah?
Is it for naming?
Okay, that's right. The DNS takes the domain name and maps it to an IP address. What did we do before that? I mean, the networking technology was around for 10 years in substantial operation.
That's our address.
Those files.
Host files, hosts.txt, hosts.txt, which is a listing of all the hosts on the ARPANET and then early internet and their address. What was wrong with that? Well, that's a technology that doesn't scale. It's hard to keep up to date, and it's centralized. And so the DNS did a change to both of those things. It took the administrative problem and distributed it, and it took the query problem and distributed it. However, the thing about the distribution that's often missed is it's a hierarchy. And I say it's missed, this group probably understands this just fine. There's an implication about administration. DNS hierarchy is distributed by delegation. It's not distributed by competition. If I have authority to do assignments in .com, no one else does. Now, I might make some of you agents of me, and you come in with requests, but there's nobody else doing .com registry. And you will hear debates, or you may have noticed in the media, debates about how we should have a shared route, by which they mean competitive assignments into the same part of the namespace. Now, I don't know about your computer science training, but mine doesn't tell me any way to solve that problem. And when people claim that they have a solution, the solution is in fact to lay a logical layer on top that becomes the central point of authority. And so they haven't actually solved the problem, they've simply moved it up a level. There are some issues in distribution on the net that are actually really quite difficult. And then we have the burst, right around the time the net became mass market. It's not entirely an accident that the web is surrounded by, the reference to the web is surrounded by all these other references. There was a mass of experimentation going on. We had some directory or indexing kinds of activities going on where Archie was the first one. Who knows what Archie is? Stop. No fair. A docent at the computer museum. Come on.
We offered Archie on SB Val.
Yes, we did, actually, that's right. So how many people have even heard of Archie? One could argue that actually Archie was the beginning of the interesting web, of the modern internet web, in the sense that it was a way of finding files. Prior to that, there was nothing on the net that let you search for files. There was anonymous FTP. From the earliest days, you could use the file transfer protocol for connecting and logging in to a remote site that was willing to make some documents public. And you could do that without having a real login, and that's where the anonymous, the username anonymous, and then anything for a password. Over time, as some security issues cropped up, they started requiring that you would use your email address, but they didn't really validate your email address. And Archie went and computed an index of the files that were available through anonymous FTP. So that was the first interesting large-scale directory service on the net. Interesting large-scale directory service on the net. Gopher actually preceded the web, and for a fair amount of time it was more popular. Anybody not involved with SVPal, since SVPal ran Gopher, anybody else know what Gopher was? And in fact, it's still around.
It's not a search engine?
It was not a search engine, no.
Oh, it's the University of Minnesota's Eagle.
Yeah, it's the mascot of the University of Minnesota where it was created. Gopher was a directory structure that would let you click down menus and eventually get to a page. And so in that sense, it's very much like the web. There were two major technical differences that made Gopher easier but less powerful. One was you could only have interesting data at the leaf, which meant that you had to do a whole lot of clicking before you got anywhere that mattered. Whereas with the web, you can have the clicking and the data be co-resident, which means you get interest value and you get reward and utility as you continue on step by step. And the other was all of the data in Gopher was text, which made it a lot easier to deal with, but also a lot less interesting.
And one other interesting thing.
Yeah.
The path to the data was always the path you followed getting there. And all the data retraced that path, whereas in the web, you go directly from your client to the server, and which is much more efficient. If you went through 12 menus to get there, that data went back through 12 points to get back to you. It's terrible.
I think I don't believe that.
I think it does.
But well, no, we could actually track this down because the protocol is documented. But the point that Phil's making is that however many intermediaries you had to go through to find the leaf, that's how many intermediaries the data went through to get back to you. And I'm not sure that's what happened, but I do know that the path you went through is the only definition of where it was. And there were lots of paths. There was no construct of a global, unique namespace. So the other key point to the web is the URL construct, which was really important. Veronica was an index, in a sense, like Archie, that was for Gopher. So it was another kind of a search engine. And Wace used serious library technology to start indexing files on the net. And in fact, the underlying engine is still in use. And then, of course, the interesting part about Mosaic was the usability. One could easily say, in fact, Mosaic, the browser, is not part of the web. People get confused because of this user interface that integrates everything, that causes them to say that email is part of the web. Well, you could say everything's part of the web, and then you haven't really said anything very useful. The technology that was created that was called the web was the URL and the HTML and HTTP. And the browser then took that capability and integrated it in with other things. And so we end up with this larger thing that we end up also calling the web, or more generally, the internet. And that's a confusion that persists today. There are people who just think that what they see on their browser is the entire internet, and they don't get the distinction between some of the underlying technologies.
You should subscribe to AOL.
Unless you do AOL. But we're at Netscape, and Netscape bought my first startup, so we won't say anything bad about AOL. I've got PGP and SSL down here because security is a fairly interesting issue in the net. The IETF has been doing, the modern IETF has been doing standards since 1989. So we've got 13 years of history. By any reasonable measure, it's an extremely successful standards group, with one exception: security. Not one single standard that it has produced, that it created, that it initiated, is in wide-scale use in security. SSL is in wide-scale use, and there's a TLS, which is a derivative, and it's generally available. I think if you actually looked at the statistics of real use, it would be quite low. There is an IETF version of PGP, but PGP is in fact not in wide-scale use, nor is SMIME. I don't have SMIME down just because this got crowded. Security technology has proved to be extremely difficult to field on large scale. It appears that there's some usability issues, and there's definitely administrative issues. I mean, the neat thing about the public key technology is it solved the problem about having to hand out these shared secrets. But it replaced it with a new problem, which is being able to certify that the public key you got is what you think it is, belongs to who you think it is. And the problem of large-scale use of public key certificates is, frankly, in my view, unsolved. And so, do I think it will be solved by 2010? Yeah, I do. Will it all be easy to use? Well, it better be by then. And so that's probably something to put in the crystal ball, where my guess is that most of this has to do with usability. Well, sorry, the other piece to this is getting most of the really intense security geeks out of the way. The problem with security is you're not allowed to fix it after it broke. Not really. And it's unlike most of the rest of computer science, where we try something and it works a little bit, and when it doesn't work, we make it better. Security is you're trying to prevent something from happening, and if it happens, you're dead. You've lost. Well, are you? Let's try an experiment. This is not as large an audience as I usually do it with. How many people in here believe that their house can be broken into? And in fact, I'll even make it harder. How many believe their house can be broken into pretty easily? Right. Pretty much everybody. How many people are worried about their house being broken into? Not very many hands going up. You're a trusting lot. Normally, many more hands would go up as a percentage. How many people have had their house broken into in the last 5 years? One. In a group of 100, I'm used to seeing about 3 hands go up. So what does this say? We say we know that we have lousy security on our houses. We live with it, and we suffer only a little bit. We do suffer, but only a little bit. That's not the approach security geeks take to designing security. Now, there's 2 different reasons for that. The not legitimate reason is they all come out of the national and military security world, where the stakes are much higher. And since that's their frame of reference, they've been trying to design a global service for that. Well, commercial security isn't the same as military security. The other reason, which is legitimate, is the leverage that crackers have because of the internet is on such a larger scale that we need to be very careful that we do have the right level of security. And since we're not 100% sure what that is, let's make it the best we possibly can. And the trouble is that's preventing its use. So I think that there's some issues in making the target security level be practical that we've been having trouble with. The other is just some basic usability and being practical rather than purist. That seems to be a pretty serious barrier. And then we had, and this was really going on simultaneously, but I tried to make it two groups. The set of information activities that were the search engines and e-commerce. Now you'll notice I have all of this under info. I think all of what's been going on, including e-commerce, is really at the level of information exchange. And you'll notice on the left-hand side it says bits. And I'm trying to take advantage of a kind of a cliche that we start with data. When we get good, we have information. When we get better, we have knowledge. And we get really excellent, we have wisdom. And that's a kind of a continuum that gets used, and I'm trying to play off of that. Most of what we've been doing has been extremely helpful, but it's really pretty basic. Now, I would claim that having ready access to search engines has proved absolutely revolutionary if it really is ready access. And in fact, it's already starting to show up on TV shows that somebody will be far more practical than the internet geek. And the internet geek might even just be a non-technical geek, but they're so heavily oriented that the only way they can get an answer to a question is go look at on Google or Yahoo, when in fact, by the way, this dictionary would take half the time. Or Yellow Pages. Sometimes are actually more helpful than Google, because it's local. So we're getting this interesting mix of capabilities, some of which are actually as astonishing as the global search engines are, and they really are quite amazing. They're still just the beginning of that area of information access. 1990, I was teaching a class to some bellheads, some phone company people in Pittsburgh. And I was brought in to be the weird internet guy, because they had all been given the OSI spiel. And so my job was to be cantankerous. And I was demonstrating Gopher, because as I said, it was more popular around that time than the web was. And I went to the top of one of the Gopher trees, namely the top of the world, which listed a set of regions around the world. And I said, okay, we're going to go wherever you guys want us to go. And you know, what part of the world do you want to go in? They wanted to go to Asia Pacific, so we clicked on that. And it's listing a collection of choices, and they decided they wanted New Zealand. And then there were a listing of cities, and they wanted Wellington. And then there was a listing of sort of users that were providing information in Wellington. And one of them was the town council. So we clicked on that. And we had access to a file that we clicked on, which was the Wellington, New Zealand Town Council minutes from last week. And it struck me that in 1990, we're standing there in Pittsburgh reading their minutes, and that this was not a technical group. These were just a bunch of administrators and politicians at a relatively small city in the scheme of the world's scope, who decided that it was worth putting their data on the net. And so if you wondered why all this stuff started showing up on the net, the answer is because a lot of individual decisions were made by regular people who decided it would be helpful. And then the idea of the search engine coming along and just chewing on all of that is that to me is the really astonishing part. Interesting thing about eBay and Amazon is that there is absolutely nothing innovative about them from a business standpoint. Auctions have been around. They deliver it in a different way, and they get a scaling effect, and they run it really well. But the key point about eBay is it takes a well-established construct and it runs it really well. Oh, by the way, it's on the net. And I'd say the same is true for Amazon. The product engineering, the product design, the attention to the user experience that both of those companies pay is just astonishing. And it has nothing to do with the internet. It has to do with really understanding how to pay attention to what your customer will react to. Oh, by the way, it's on the net. Now, could they exist without the net? Well, of course not. The connectivity is really important to it. But they don't sell you the internet. They don't sell you because they're on the internet. They merely make it easy for you to use that because they're on the net. And because it's easy and it's well run, there's a lot of you that want to use it. I have down SIP, and I added that only after I showed up because, let's see, by the way, how many people know what SIP is?
Two meetings ago.
Oh, VoIP, that's right, you had a voice over IP. SIP is a protocol that is at the forefront of internet telephony. It is really a coordination protocol. It's not actually a data transfer protocol for streaming. It's for call setup and teardown, in effect. And it's a pretty good protocol for that job. Unfortunately, it has become a religion. And so people are trying to use it for everything. And my experience is that when you have something that's really good at one thing and people try to use it for lots else, they end up even making it bad for its original job. And in fact, in this case, the people who are the proponents in the IETF are hurting the IETF. They're shouting down new activities. I mean, it's total religious fervor. Nonetheless, it's being deployed and it is useful. And so one of the things that's cropping up, I think, quickly is multimedia. The simplest version of that is just a PBX on the LAN. And that's already proven useful. There's been some anecdotes floating around about natural disasters that take out the phone system, but you can still make a call because it's going through the net. Now, the counter to that is the phone system has been designed to be managed in a certain way during disasters. So even if those resources are there and running, you may not be able to make a call. 1989, we had the earthquake here. A guy named Van Jacobson was well known in the internet technical circles for some extremely good work, especially in the late 80s and more recently in multicasting. Late 80s, he did some really important work on making TCP work at higher speeds. One example is that the highest performance you really got out of TCP prior to his work was 2.5 megabits per second, and when he got done, he got 9.5 megabits on Ethernet. A 10 megabit Ethernet. That was pretty astonishing.
What else is on that Ethernet?
Nothing. And that, in fact, that increase in performance led to discovering a bug in the Ethernet technology. And Metcalf says he knew about it, but nobody ever thought it would be a problem because no one would use the net that fast. So he was lecturing at Stanford, but he actually lives in Berkeley, or lived in Berkeley then. And so when the quake hit, of course, the first thing he wanted to do was make contact with his girlfriend, make sure she was okay. So he tried to make a call, and he couldn't. And by the way, those bellheads in Philadelphia got very upset with me, and I said, well, you know, the quake took out the phone system, and they explained, no, there's an emergency procedure on the phone system that you shut off regular access to keep it available for emergency use. And since that time, I've actually had a client at the National Communications Service who was responsible for taking that facility, which is called GETS, and making it work on the net. Out of frustration, feeling like he had to do something, he sent email to her. He didn't expect her to get it. I mean, he figured the net would be down too. He had an answer in 10 to 15 minutes. He was so astonished that he did a trace route. And by the way, he's the guy who created traceroute, for those of you who know what that is. And he wanted to see what the path was that went from Stanford to Berkeley. And sure enough, the path was down to LA, across the country, up a little bit on the East Coast, and back over to Stanford, to Berkeley. It all worked. Dynamic routing at its best.
You know, a lot of cell phones work. People who had cell phones and made calls could get through.
Right, cell phones. And an interesting issue is cell phones each base station has to be tied into the home system. And that was one of the distinctive features about Metrocom, because Metrocom could do wireless-to-wireless relay. And that's not something that's in the phone company approach. But we know where Metrocom went. Okay. So let's now try to. This is going way over. What's the time like?
As long as everyone's having fun, go ahead.
What's normal?
I'd say 35. Take another 20 minutes.
Okay. So I think that it's important to look at the administrative history a little bit, because that's where some really major changes have happened and generally not been recognized. Now we know we had the ARPANET in the early 70s, and the flag date for the modern internet is January 1983, January 1st. Now, I'd like you to notice what the date is going to be in about 2 weeks. 20th anniversary of the modern internet started.
What makes it the modern internet?
Okay, what makes it the modern internet? The TCP/IP was required on, oh, sorry, let me rephrase this. The infrastructure would no longer pass the old protocol. The underlying protocol, which is generally called NCP, wasn't really the name of the protocol. The name of the protocol was host-to-host protocol. But NCP was the software, and so that's what it got called. It got very confusing when IBM chose the same name for their stuff. And the internet was divided between MILNet for the military and the research network, which was called ARPANET. And so, and for 6 months, the internet was largely useless, because it turns out they really did do it as a flag day. They turned off the ability to send old protocol. And they did this just to beat people up, to get them to make the switch, because they've been trying to be nice guys about it, and nobody was making the switch. And that was with a few thousand users. Imagine trying to do that today. And the lesson that comes out of that experience and any other operations transition of any scale that anybody's ever done is when you have a large system, a transition is the same as cohabitation for a long time. Because whatever it is you've been running, you're going to keep running. You introduce something new, it's very possible that the old stuff will never go away, but it's certainly true that it'll be a long time before you can pretend that it's dead. So we've got IPv6 coming in, the new version of IP, and it's enough different from IPv4 that it really is a different protocol. There were some people who wanted a different approach, but they lost that battle. And so now we're going to have this issue of why bother with IPv6, and oh, by the way, it now doubles my operations cost as a provider because I'm now having to support 2 protocols. And there's a huge amount of staff and software involved in running each protocol at that level. So, how many people have heard of...
Let's talk about how IPv6 coming in is, as I understand, it's going to be more like pockets.
IPv6, okay. Has anybody not heard of IPv6? Okay. The current internet protocol, the standard unit of data that goes across the internet is Internet Protocol Datagram. And the version of that protocol that we've been running for many years is IP version 4. The number 5 got consumed somewhere, and so the next version is IP version 6. The effort to create IP version 6 was prompted by running out of address space for IP version 4. There's only 32 bits of address space. Now, 32 bits of address space will support, I think, 4 billion if you use the numbers all completely efficiently, but we don't. We partition it into a hierarchy, and that creates inefficiencies. And there are various estimates about when we run out of addresses. And one of the mistakes that was made with respect to planning IPv6 was doing a calculation that said, when will we no longer have any more addresses? And the number that came out was 2010 or 2020. But that was the wrong question to ask. Because what you want to know is, when will users of the net start having trouble getting addresses they need? And it turned out the answer to that was 2 years before the analysis was being done. At the time this debate was going on, good users with good reasons for getting multiple addresses were already being turned down. So that's a case where there was certain kinds of politics, but actually I think it has more to do with limitations of human thinking. Where it's not so much whether you can do statistical analysis, it's whether you know what statistics to look at. And in this case, a whole body of very good people didn't. And they were really resisting any statements to the contrary.
So when was that analysis done?
I want to say 95, 94. Had there been a more aggressive sense of urgency about the need for IP version 6, we probably would have fielded the original spec that gained any popularity. I'll skip over the politics that happened with an earlier draft. There was a version a guy named Steve Deering produced, which was truly elegant and beautiful, and it's the core of the current IPv6. By the way, it was Steve's IP, or SIP.
Oh.
Very confusing now.
Oh.
And he fixed the address space problem, and the only other interesting thing he did was make the headers more efficient. So he took away the checksum on the header, which was one of the most counterintuitive things I've ever seen an engineer do. And it turns out that he then had this argument for why you don't need that checksum. And basically it was, well, you've got all these other checksums. This one is a waste of effort. The other thing he did, and he was right, the other thing he did was to take option handling and take it out of the fast path and take it out of the critical path so that you could have options that were handled by intermediaries but not the next intermediary. And it didn't hurt the activity. And it made options extensible, which the current version of IP does not have. So IPv6 got delayed because people said, well, we're only going to be able to make one change to the net, and so we have to make all the changes at once. This is the Flag Day construct, and it killed the effort for 6 years. So we are only beginning to get IPv6 now. We don't have the market pull that we need to have. And as Bill says, what it's looking like is we'll get it in pockets. And what those pockets will be is whatever they will be.
Do you want to mention that?
No. I will in a moment. There is a slide. Yeah.
Is it true that China has already introduced IPv6?
There are certain places in the world that are quite aggressive about adopting it. And I apologize, but I'm not as knowledgeable about that as I should be. I know Japan has been actually the hotbed in the world for adopting it. And they're just really pursuing that aggressively. I would expect any place in the world that's creating internet infrastructure now would be in a good position to start with IPv6. But I don't actually know any details about Chinese activities on that.
Don't you think that without introducing IPv6, the US is going to be at a major disadvantage with wireless technology, which they already are in many cases?
Okay, let's ask a little bit about, so you mentioned wireless because that's a medium, and then you're saying a disadvantage with IPv6. Most users, most wireless users, virtually all wireless users are clients. You don't actually need a large address space for clients. That's why NAT is popular. Now, it introduces some problems, and the problems are significant. But basically, for clients, you don't really have as much of a problem as you do for servers. The servers need stable addresses. Now, that gets interesting when you start talking about every power control unit in the country being queried by the Home Office. That's something the electrical folks, back when we were trying to have this debate, the EPRI, Electrical Power Research Institute, came up and said, we want an IP address for every power pole. And we can't get them. So that's my example of we already have the problem. To query those units means they have to have a stable IP address. So I actually think that it's the very, very, very large scale of control monitoring and those sorts of interactions that are going to create more of a demand than wireless per se. Now, if peer-to-peer gets super popular, then everybody's a server. And then you're back to that problem. But I'm less sanguine about that. So let's go to NSFNet. Who knows what NSFNet was? Wow, times have changed. So a measure of progress is when fewer and fewer people know obscure data about the history. NSFNet was, generally it's reviewed as the successor to the ARPANET, in the sense that the National Science Foundation funded an internet backbone and regionals. Several of the regionals became commercial networks eventually, but they created, I don't know, something like 5 regional networks and 1 backbone.
Barnet.
Barnet was one of them locally, Bay Area Regional Network. NYSERNet, and so on. Anyhow, SUR was Southeast Regional Net, I think. And that was in 1987. As many people as might know about NSFNet, they don't know that there was actually something that was equivalent to market research done before that. Because remember I said people couldn't get on the ARPANET, but they wanted to. So this whole class of second and third tier universities and others who wanted to be able to do email and file exchange and so on the ARPANET and then internet, and they couldn't because of the rules and the cost. And so there was a project called CSNet for Computer Science Network which began around 1980. And initially it was for email relaying. That's all it could do for several years, was just email relay. And over these dial-up lines where you could only do 1200 bits per second. But it turns out that 1200 bits per second in the background, which is what email does, is okay. You can transfer a lot of data. Not if you're doing JPEGs and GIFs, but we didn't have that problem back then. If you're doing simple text messaging, you can do an enormous amount of traffic at very low speeds, as long as it's in the background. And so a whole national service was set up and run by CSNet, hooking in a lot of these organizations, and then doing gatewaying onto the ARPANET and then the internet. That was sufficiently successful that NSF said, we need to make this full-fledged so that more people can get directly attached easily and have full access, that it isn't a secondary access the way CSNet provided. And that's where NSFNet came. Well, sometimes you will see references that explain that by virtue of NSF doing this, we ended up with a precursor to ISPs, commercial ISPs, because of several of the regions becoming. But there was a more important technical point, which is generally not recognized, although it's starting to get a little bit of acknowledgement. And that is NSFNet broke the internet backbone. And this was a good thing. Up to that point, there was one internet backbone run by both Baranek and Newman, the same folks that ran the ARPANET. They controlled the routing protocol. And the routing protocol was designed for one backbone. So here comes NSFNet, and it's not run by a BBN, and it's a second backbone.
Oh, David, the BBN protocol allowed for one backbone, but the whole concept behind the ARPANET was to not allow the atomic bombs to blow out the network at any single point of failure.
The reference to the ARPANET and atomic bombs doesn't match any of the experience I had at the time, although I have seen one reference to it. The phrase that was used at that point in time that I was used to hearing was that the ARPANET was designed to have communications survive hostile battlefield conditions. I don't think anybody seriously believed you'd survive an atomic bomb, because nothing survives an atomic bomb.
But it was a mesh network.
Survives an atomic bomb.
But it was a mesh network. You were supposed to go around the city and get blown away.
Well, but at that level, you know, when you're predicting nuclear holocaust.
All right.
But by the same token, we do know that the technology survives a hostile battlefield condition because it was demonstrated in Desert Storm. Saddam Hussein's network survived just fine, thank you very much, and it was exactly that technology.
It was a big problem.
It was. But the routing protocol that interconnected, and we now have what's called BGP. Well, BGP was the result of NSFNet being attached, and it was designed to take multiple backbones. And why that's important is that really, in my mind, was the beginning of the competitive internet. Because now we can have anybody be a backbone, and that's okay. And they could have people under them, which is where we get the regionals and the locals. And there was nobody in charge, really nobody in charge of the operations side. Yes?
Isn't there this Internet 2 that's being worked on?
Yeah, Internet 2 is a high-speed research project, and I have not yet been hearing about interesting applications. And so my current attitude is it's just more and faster.
But it's totally separate. They can't plug it in.
I haven't been tracking the details. I don't know if there's any connections or not. I know the idea is that there's not, but it's too easy to interconnect these things. Yes?
When you look at that timeline and you look at functions, what would you say would be some functions down the road that you haven't seen?
Hold on. Even though we're taking too long, there is some. You're not going to like what I have, but I do have something. Okay, I have the IETF and W3C because I wanted to throw something in about the standards world, and the reason I wanted to throw that in is because that's a major piece of the sociology of building the net. And if we're going to keep building the net, we're going to need that sociology. Standards are a major part of any growth like this because you have to have common reference points, common standards, which means you have to have a venue for that. The IETF has frankly run out of steam. There's too many standards to make. Too many people who don't know how to do it well, and so even if we fix the IETF, it's not going to be able to encompass all of the standards we need. Now, it turns out that the reason the W3C was created for doing web application protocols was because they were frustrated with how long the IETF took. Yeah, which is why it's amusing if you look at how long it takes things to be done in W3C. And Berners-Lee has acknowledged that perhaps they were just a bit too simplistic in their model of what it takes to get standards done. But they made up for it because so many of the things they've come out with have been so poor. XML is great, but a lot of the other stuff ain't so great. I mean, from a protocol standpoint, SOAP is really poor.
Think about P3P.
And I think I'll stop there because I'm not involved with W3C, and I'm not actually trying to slam them, because what's interesting to me is not, oh, they're terrible and IETF is wonderful. IETF actually has got very serious problems right now, and I consider them scaling problems. You have later generations that are not as skilled and don't understand some of the core constructs. And so, in fact, what they're doing is natural kinds of design. Well, natural kinds of design, if you're trying to be diligent and all-encompassing, is you build a big system. And the thing that was interesting about the IETF when it was doing well, and still is when it does well, is that that's not the approach it takes. You take a big problem, because the problems are big. It's not wrong to say this is a big problem. What's wrong is to try to solve the whole thing at once. That's the normal thing to try to do. The right thing, which frankly the internet folks, I think, tripped into by virtue of needing to deliver something soon, and it matches exactly what the real world of product developers does when they have tight funding and need to hit a market window, is you take this big problem and you look around and you go, I can solve this a little bit right now and it will be useful and it will get me going. First of all, get me revenue. Second of all, I'll learn more about the problem domain, and I'll learn a little bit about the solution domain. And then I can build the second part of the solution, and the third, and the fourth, and build out. And by the way, if I get this one wrong, I haven't invested too much. I can go try and solve one of the others. That's a philosophy that anybody who does serious product work considers normal. But in the standards arena, it's not normal. And then there's the administration of the well, what's called Internet administration, and it's things like numbers and names, who hands out domain names, who hands out IP addresses. And the reason that that's worth paying attention to is, first of all, it's been abused in by the media, by the print media. And the third is, it requires a different structure than the rest of the net. The rest of the net is legitimately competitive. You can have multiple backbones, multiple local ISPs, multiple providers of PCs and software, and all the rest of that. No need to coordinate any of that, other than making sure they have common technical specifications. And even there, you can have competitive specifications and let the market choose. You cannot do that for the administration of names and numbers, because they're hierarchical, and we don't know how to have the market decide which address space will win. Because in the interim, you'll have ambiguous addresses and you'll have disconnections. You have discontinuities in connectivity. And the internet had, the original administration was done through SRI, and then eventually done by a small group, which is often referred to as a single guy, but it was actually several people, a guy named John Postel at USC ISI. And the name of the group was the Internet Assigned Number Authority, or IANA. And he was doing that work going back into the early 70s, but since we're focused on the modern internet, I'll just say he was doing it, the interesting level of this was done when the DNS was created more than 15 years ago. And by the way, it looks like it's more than 15 years, but that's when the spec was done for DNS. It actually became useful in the late 80s. That work, that administration went fine. He was referred to as the number czar. And the term czar has caused some people to think that he was like some kind of dictator, but in fact he was highly collaborative. And when he made a decision that sort of cut through people's debate, he was allowed to do that because he made good decisions and we liked him. And I don't just mean like him personally, it was he made good decisions. And we all wanted a decision. So you debate for a while and then you move on. This all got turned into a huge political play when NSF allowed now VeriSign, then NSI, to start charging for domain names, simultaneous with court cases starting to intrude on some issues of intellectual property, namely trademark. And what came out of that was involvement all the way up through the White House. Ira Magaziner, senior White House guy, who had done such a great job of getting universal medical care in this country, that he went on to fix domain name administration. And he did that through by taking a year's worth of U.S. federal government interagency work and throwing it out, because he's brighter than they are, and saying, okay, here's a paper that's going to tell you how everything's going to work. And it was called the Green Paper because it was a draft proposal. What eventually came out was a white paper, and out of that came the organization that now runs this stuff on, quote unquote, on behalf of the U.S. government, called ICANN. What the Green Paper did, and the reason it's on this list, is that it destroyed IANA. 15 years of good operation that needed to evolve and was in fact being orchestrated for evolution was disrupted like that. Its authority base was taken away, and what we got in its place was this mythology that the U.S. government was really running this stuff, which it hadn't been. The reason that's important is it's now created an instability in a fairly important piece of infrastructure. The other reason is you hear people refer to ICANN as doing internet governance. And if you've seen those references, you want to distinguish between what is it ICANN really does, which is to administer names and numbers, and then say, now, if the people who hand out 800 numbers and hand me out my street addresses, if I said they were doing national governance, would anyone take me seriously? The answer is no. Hello. All right, so this is not the kind of specificity you probably wanted for the predictions of the future. But then I figure 8 years from now is far enough away that I'm not going to tell you what kind of products they'll be because I have a clue. But what do I think the opportunities are? What kinds of things are the opportunities? The uninteresting opportunities that we're going to get more, better, faster. So we're going to have things everywhere. We're going to have the internet everywhere, where wireless becomes sort of the easy reference to that. But it's just everywhere, all the time, anytime you want it. Let's see, I guess McDonald's has a market goal that it's no more than 4 minutes to the next McDonald's. Okay, well, my guess is it's probably no more than 45 degrees of arc of turning to the next internet access point. Integration. We're starting to get internet in devices that are not inherently internet devices. They're not PCs. And so ViewSonic just announced a display that's actually capable of being another internet display device in your house. I assume they use wireless in the house for that. We're starting, the standard joke is about internet in your refrigerator. Well, that may be a joke, but let me tell you, we had 2 power outages in the last week, and personally I found it kind of irritating to have to keep resetting the clock in all these different devices. Now that may sound like a trivial example, but in fact it was work, and I probably got it wrong, and there is some potential repercussion as we have more and more sophisticated controls in devices. Let's see, I have Replay TV rather than Direct TV, rather than TiVo, and I can come in over the net and set up for reservations of what's to record, and I can do that from anywhere. So when I'm traveling, if I discover there's a show that's going to play, I can tell my Replay to record that. Well, that's a kind of integration, and everywhere. Now, what do I mean by synthesize? Actually, what I mean by synthesize, since integration is up there ahead, I actually don't mean putting things together. Synthesize, what I mean by that is bringing information together and doing interesting things with it. And by collaboration, I mean people being able to get things done in a collaborative way that they couldn't do easily or at all now. And I have some more about that. Now, DMCA is the Digital Millennium Copyright Act, and it's down here as just a reference to intellectual property and legal issues. What we're seeing is, especially because of September 11, is so much fear that we've got some really bizarre stuff going on. And I'm not trying to slam DMCA as much as point out that it highlights a trend towards information control that is sort of the opposite of what the internet has been about. And that's a tension that I think we're going to see for quite some time. And since I was born just before the McCarthy era in this country and lived in Los Angeles, and actually my parents knew people who I was told I can't say that they've actually been putting on a play in the church. I'm a little concerned about the implications of this kind of control over people's activities. The 6 orders of magnitude is a reference I really like. This actually, we may even be as high as 7 right now. From its start to roughly 5 years ago, the internet went through 6 orders of magnitude of growth, and there's only 2 more before it covers everybody on the planet. And I just think that's kind of an astonishing number. How many systems do you know that could have continuous operation through 6 orders of growth? That's pretty amazing. One of the other lessons is when you have all of these layers, is for interoperability to take place, you have to have interoperability at all of those layers. If you break any one of them, you don't have interoperability. As the internet was getting started, and you still run into this occasionally with things like Microsoft doing proprietary changes, is you get the statement based on open systems. Based on is a code word, which means proprietary. It means we started with open systems and then we made it closed.
We took the open system and made a product out of it.
That's right. And then another one is that there's a social impact of all of this access that is really tough. And that is either you have to get more parental or you have to get better inoculated. By more parental, I mean somebody has to decide what to regulate that you or your children or your neighbor can see or do. Because there's going to be people who will abuse it. And if you're trying to prevent that, they're going to prevent more than just the abusers. They're going to prevent the good people. And so that's a kind of parental process. Personally, I think they're not very effective because I think the downside is so large. None of these controls are really surgical. They sweep too broad. And what that means is, yes, we'll filter your spam, but now you can't do research on sexual diseases if you have one, for example. That's a recent study that just came out. Is all of that good pornography control is in fact preventing people from doing legitimate medical research. All of this good spam control prevents you from getting newsletters you've signed up for because there are no technical differences between those 2 objects. Neither the message is different, nor the traffic flow is different. So trying to distinguish between spam, the bad stuff, and subscriptions, the good stuff, is tough. The other issue, the other approach is to say we live in a noisy world. And that's a fact we're going to have to deal with. And it means that rather than, I'm going to carry this to a very dangerous extreme, but I'm trying to make the point. Rather than try to prevent children from seeing pornography, is we have to have children no longer care about pornography. Now that's asking a lot, but it turns out that that is something that's possible, and I'm not sure we have a choice. Because they're going to get at it anyhow. That's the downside of the increased access we have. Okay, so what was interesting in the diagram that I put up is, in fact, we don't have major breakthroughs very often. And I'm saying 20 years because it looks like that's a reasonable guess. We had the original work in the 70s, and then we had a whole lot of work after that, making it more, better, faster, but not different. Notice that we had a whole bunch of applications in the 1970 time frame, and we did not have any interesting new applications until 1990. The only exceptions were DNS and email, and I'm sorry, email was just more, better, faster, and DNS was just more, better, faster. 1990, we started getting some information services, a whole bunch of effort on that. And so my guess is somewhere around 2010, we're going to be ready again. And then until then, we're doing more, better, faster, and maybe we can try to, have little pockets of innovation. But I'm not too hopeful. So we need all of that speed, improved reliability, improved scaling. But it's not the paradigm breakthrough. It's just more, better, faster. I've already said about how long it takes to change the infrastructure. As wonderful as the web is, it's really quite horrible. The web is a central service. You don't use, your PC is an access device. It's not a computer anymore. And you can say, well, we download Java and this and that and the other. But fundamentally, it's a server farm somewhere. It's a central computing facility, and you're the client. And so the web has turned the world into a collection of server farms, which is central computing. And the web, by the way, isn't very useful if you're not attached to the net. Now, that might sound like a really silly thing to say, because the net isn't useful if you're not attached to it. But I will point out to you that email is extremely useful when you're attached only part-time. The web is not useful when you're attached part-time. And you might say, well, what about all those offline files and cache? And the answer is, yeah, a little bit. But that doesn't work all that well. It turns out that moving to real distributed computing, and peer-to-peer is intended to be that, whether it really achieves it is not clear, but real distributed computing is vastly harder to do interesting things with than client-server or centralized computing. And to hit a social point is, one of the downsides of all this stuff on the net being available is all this stuff on the net is in front of my face. You have to know how to configure your computers, you have to know how to know what passwords to remember everywhere, you have to know the idiosyncrasies of using the reservation system with United Airlines, which is different from American Airlines, which is different from Orbitz. There's just an incredible amount of detail that we're now overwhelmed with. So in fact, all of this wonderful stuff is becoming a problem because there's all of this wonderful stuff. Well, he might fall. We might not be able to put him back together. Okay, 7-layer model. I assume most people have seen this. This is the core of the technical work. It came out in 1976 from the ISO world. And it was very interesting. Prior to the 7-layer model coming out, conversations around the ARPANET were quite predictable when we were talking about networking. You'd spend the first half of your conversation getting a common sense of terminology, and the second half using it to talk about whatever you were interested in. After the 7-layer model came out, you'd spend the first half of your conversation complaining about the 7-layer model, and the second half using it. Well, it's become common these days to talk about 2 additional layers. This as the net became large and commercial. And in fact, there's a T-shirt that's been distributed which has these and says, "You're here," pointing to political. When the political wars that surrounded the activity that became ICANN, so the domain name politics, which went all the way up to the White House and the European Union and so on, when they hit and I started watching the way people were behaving, I decided that, in fact, this went beyond politics, that we were entering another realm of pure emotion and rigidity. And this is worth thinking about because I think as the internet becomes more regular in our daily lives, the issues are in these upper layers, not really the interesting issues at the lower layers. So I told you about the data, info, knowledge, wisdom, and that explains why in the 2010 I put wisdom under it. I sort of skipped over info. What we do see with a scaling effect, whether it's faster or more or better, is some differences in degree do in fact have the effect of being a difference in kind. The email world, and I forgot to add MIME, which is a major breakthrough for multimedia email, and also a major breakthrough in how to upgrade an infrastructure without changing it. And so, let's see. This was trying to elaborate on those 4 points about ubiquity, integration, and synthesis. The synthesis, I've just spent now a couple of years working in a company that used knowledge management technology. For those not familiar with that technology is, you think of it as semantic searching rather than string searching. So a way of relating data through its semantics rather than just finding keywords. The standard example that I was given for that is, imagine doing a search on Osama bin Laden and you get a whole collection of results that are about terrorism but never mention Osama bin Laden. So there's a semantic relationship, but no keyword relationship. I think there's a huge amount of potential there. It's also tough technology. But much of what the internet has become is about information management and information synthesis, and the knowledge management area, I think, is required for that. I also think that somehow there's something else, some piece of magic I'm going to call intuition, that we're going to start finding ways of programming, and it goes beyond semantics. And I don't know what I mean by that. I just think it's an interesting area to explore. Collaboration is not just people interacting, it's also processes. And workflow, which is the term we're used to using, is a touchstone into that area. Agent technology, mobile agent technology in particular, where you can send things around. Imagine that if you want to set up a meeting, you send around an agent that knocks on the door of every possible participant and talks to their agent and figures out when we can all get together. This has been a scenario that I've been trying to describe for 10 years. And I believe that we are really close to being able to do that. There's some obvious security issues because what do we call when I send you a program that runs on your machine but you didn't ask for it? We have a name for that. Virus. It's actually a worm, but we call all of those viruses. And so we want to be careful about agent technology, but the potential is really huge. Okay, so for planning the next big thing, my first comment is pretty much nothing that has happened has been planned. It was more a case of create an environment and good things will happen eventually if enough people work on it diligently, and that's what's happened. And so every time we've tried to plan something, we've screwed it up. IPv6 was a plan. The original version of IPv6, if we had deployed it, would have been a wonderful next step, allowing increments. So rather than trying to plan the next big thing, let's try to react and observe an opportunity and do the next small thing that can become the big thing. There is a construct in internet technology that end-to-end is king. And so that's why TCP only sits at the ends and not in between. But the thing that people forget when they talk about that, and that's inside the technical community also, is TCP is running over IP, and IP is not end-to-end. End-to-end is an absolutely important construct, but it's virtual. Everything that is end-to-end, everything that has the two interacting sides on the internet is virtual end-to-end. And so the web, client-server, that's interactive, end-to-end. My client interacts with your server. Well, excuse me, what about gateways and NATs and caches and proxies? The web has become intermediated, but it's not designed for it, which is why it's having so many problems in that area. So if you design applications on the assumption that there will be intermediaries, you'll do better. By the way, I have an email bigot in case you hadn't noticed. And however good the bandwidth is that some people have, it won't be what everybody has. The internet is about constrained channels. Don't ever think otherwise. One of the things you may run across is some people claiming that the way we get voice and video on the net is to just make sure all the pipes are big enough. This is a very serious point of view, claiming we don't need quality of service controls. It's an incredibly silly idea. All of packet switching is based on the idea of sharing constrained resources. Queuing theory, which is at the core of this, is about handling transients. And there are always transients that go beyond what you can handle at any one moment. So one of the things missing from the net today is serious quality of service, and we haven't figured out how to change that. And a few references that you'll be able to get off of the webpage. Sorry I ran so long.
Thank you very much. Are there any questions?
Yes.
The telecommunication, like since 2000 until right now, about 2 years, the market value for telecommunication amount lost about 4 trillion. That's account about 60% of total. That's like loss. From a technology point of view, what happened? It seems to me nothing happened for the technology, but the market value lost 4 trillion. For example, right. Cisco lost 500 billion. That's about half trillion. A Cisco equals 4 trillion.
Well, one thing that's important to notice is we all still had internet access. We all still could buy routers. And so, I mean, part of what happened was things were too expensive and now they're maybe too cheap, but they're still happening. Right? The services are still there. I think the real effect is that the burst of innovation or the continuation of innovation is where we're suffering. It's essentially impossible to fund a startup in the Valley today. and which is why I had to stop doing what I was doing. And angels have disappeared.
Depends the point of view. I think should we have some big mistake, otherwise you cannot get the instrument. What's the major big mistake from technology point of view for telecommunication internet infrastructure? Have you found any big mistake, or what's your opinion for?
It all
People
works.
believe momentum was everything.
Right.
They stopped thinking about financials and thought about
Like
just
when the
momentum.
people talk about .com, they talk internet.com. .com knows some money, but most of .com they are startup. They are not going to market yet. So it will not
No, but
come
the telecommunications world was riding the same wave of focusing on growth rather than focusing on profit. Because they were investing for the future.
The worst section for the startups.
Before things get any farther along, we like to recognize the effort people put in like this, so we'd like to thank you very much for coming and talking to us.
Thank you.
Any other questions? I got one or two messages, and then we'll pick this up. First of all, I won't give you first shot. Usually I give you first shot to talk about my project. Tomorrow morning at 9 a.m. there's going to be a meeting of 4 or 5 people who responded to my last email and said, I'd like to get